Okay, good morning students. So మనం last class లో we discussed about the topic so that is called as a vectors and properties of the vectors and example of the vectors and so some problems is faced on a vectors. So now today another problem is taken, so that is called find the torque of force. Find the torque of a force 7I plus 3J minus 5K about the origin. The force acts on a particle whose position vector is I j plus k. Okay, I minus j plus k. Okay, so find the torque of a force 7I plus 3j minus 5k about the origin. Find the force, torque of force. Okay, find the torque of force 7I plus 3j minus 5k about the origin. The force acts a particle whose the position vector is I minus j plus k. So by using the determinant method, torque tau is equal R cross F. Torque tau is equal R cross F. So F is equal given 7I plus 3j minus 5k. And so the position vector R is I minus j plus k is taken or given. So to find out the torque force, that is the tau is equal by determinant method. So torque is equal R cross F. R is called as a position vector, F is called as a force. Okay, got it. So the torque force example already we know that in a last class. Okay, so the torque tau is equal R cross F. So that is equal I j k is taken, 1 minus 1 plus 1 is taken, and 7 3 minus 5 is taken. Got it? I j k 1 minus 1 1. Okay, and 7 3 minus 5 minus 5. So by using the determinant method, okay, det method, so I into I ante, so that means a column e row, these two rows are cancelled, so remaining these only remaining 4. So 1 into 5 minus 1 into minus 5 plus 5 minus, so 3 into 1 3 is taken. Always j is taken minus into, so j these two rows are cancelled. Okay, so remaining 1 into 5 minus 7 into 1 7 is taken plus k is means these two rows are cancelled. Okay, remaining only 4. So 1 into 3 minus 7 into minus 1 minus 7 plus 7 is taken. Minus into minus plus. Okay, so 5 minus 3 is 2i, and so 7 minus 5 12 minus 12 minus j plus 12j. Okay, so 7 plus 3 10 plus 10k. So this is called as a torque force. Why? plus 12J plus 10K is the torque force. Okay, to find out the determinant rule. So another topic is angular velocity. Angular velocity. So angular velocity, the rate of change of angular displacement, angular displacement, the rate of change of angular displacement is called angular velocity. Got it. So that is called as a so d theta by, or so the change of angular displacement d theta by dt is equal to omega. So that is called as a angular velocity. So units radian per second. Okay, radian per second is the units of angular velocity. Okay, so the rate of change of the rate means the time with respect to time. So the rate of change of the angular displacement. Okay, the rate of change of the angular displacement. Angular displacement means so कोणीय स्थानभ्रंश. Angular displacement is called as a angular velocity. And now prove that V is equal to R omega. Okay, so now we are taken here. Observe the. This is called circular path, and the radius is taken R. Okay, so now here consider the object or body or particle P is moving on the circumference of the circle. Okay, so the angular displacement in a displacement ds in a time interval dt. Okay, so consider the particle is moving on the circumference of the circle. Okay, so through the displacement is the ds, through a displacement is the ds in a time interval dt. And so the radius of the sphere is r, and angular displacement is taken d theta or dt. Okay, got it. So the particle moving is on circumference of the circle. Okay, so the p is the moving particle in displacement ds, in a time interval dt. So in a displacement ds in a time interval dt, and so the circle is having the radius is r, and angular displacement is d theta. Okay, got it. Now here taken according to the rule of the circle. So that means arc length by radius, length by radius. So that is equal arc length by radius. That is called as a angular displacement. Angular displacement is equal arc length by radius. So angular displacement is taken d theta, arc length is taken ds, radius is taken, that is the r. Okay, so that means ds is equal r d theta. Okay, from the circle. Okay, ds is equal r d theta. And so the differentiating both sides. Differentiating on both sides with respect to time. We got it. So ds by dt or d theta by dt. Okay. So ds by dt is nothing but displacement by time. Change in the displacement by time is called as a velocity. We can write. R is the constant, that is the radius. D theta by dt is nothing but we can write omega, angular velocity. So V is equal R omega. Now prove that. Okay, got it. So what is the angular velocity? So the rate of change of the angular displacement is called as a angular velocity. So general equation, displacement by time is called as a velocity. Angular displacement by time is called as a angular velocity. So radian per second. And so now prove that V is equal to R omega. So consider the body is moving on the circular. Okay. So through the displacement ds in a time interval dd. Okay. And so the circle, radius of the circle is R and angular displacement is d theta. Okay. Center of the circle is taken O. And according to the rules of the circle, okay, so the angular displacement is equal arc length by radius. Arc length by radius. So the d theta by ds by r, ds is equal r d theta. And so equation 1, and so this equation 1 is differentiating on both sides with respect to time. So ds by d theta is equal r into d theta by dt. So V is equal, ds by dt is nothing but change in the displacement with respect to time is called as a velocity. So velocity V is equal R omega. So omega means the d theta by dt is equal omega. Now substituting in the equation, so V is equal R omega. Got it? Okay, right. So now all of you listen to here. So find the center of the mass of the three particles at the vertices of an equilateral triangle. The masses of the particles are 100 grams, 150 grams and 200 grams respectively. Each side of the equilateral triangle is 0.5 meters along. Okay, so what is the center of the mass of the three particles? So first of all, center of the mass of the particles of a system of a one that is means on a x-axis or on a horizontal or along the one axis, one dimension is taken. Okay, so that is means here center of mass of the coordinate system. Center of the mass of the coordinate system. So center of the mass of the particles or lies in a only x surface is taken. So x cm is equal, center of mass is equal. So m1 x1 plus m2 x2 by m1 plus m2 is taken. xcm is equal. That means so the particles are lying only in x-axis or one dimensional. One dimensional. So center of mass is equal m1 x1 plus m2 x2 by m1 plus m2. If we consider the number of the particles plus dash dash of the mn xn by mn is taken. Okay. So now here consider the two-dimensional system. Two-dimensional system. The two-dimensional system, center of the mass consists of the system lying on a x and y axis. Or two-dimensional is taken. So that is equal xcm and xcm is equal m1 x1 plus m2 x2 by m1 plus m2. Similarly, ycm is equal m1 y1 plus m2 y2 by m1 plus m2. So this is a two-dimensional system. Two-dimensional system. Okay, good. Center of mass of the two-dimensional system. If we consider the number of the particle, so n x n by mn. So m n y n by m is taken. Okay, got it. So if we consider the three-dimensional system, okay, x-axis, y-axis, z-axis. That means so the coordinate system, okay, or so the center of mass of the system is a line on a so three coordinate system, three-dimensional system, x-axis, y-axis, z-axis respectively. So that is called as a okay xcm is equal m1 x1 plus m2 x2. Okay, x2 by m1 plus m2 remaining. So ycm is equal also zcm is equal, we can write. Okay, got it. So now we are given that information. So three particles are given. Center of mass of three particles. Center of mass of the three particles are given. Okay. So first of all, we taken the circuit diagram. So three particles are placed equilateral triangle. Equilateral triangle. So here given that is the center of mass of the three particles. So equilateral triangle of the masses of the particle here taken. So that is equal to m1 is equal 100 grams. m2 is equal 150 grams. m3 is equal to 200 grams is taken. Okay, so masses of the particles and each side is taken 0.5 meters. Okay, O, A, B, C is taken. Okay, equilateral triangle. So here that is called as a coordinates x1, y1 is equal to 0, 0 and x2, y2 is equal to find out. x3, y3 to find out. Okay, so by using the center of the mass, first of all given masses, so m1 is equal 100 grams, m2 is equal 150 grams, m3 is equal 200 grams. Okay, so each side is taken, so the length 0.5 meters. Okay, got it. So now here, so m1 x1, and that means x1 y1. So coordinates of x1 y1 is equal 0 0, because that is called as at origin is taken first of all. At origin. So 0 0, and to find out the x2 y2. Okay, x2 y2. So x2 y2. So x2 means so on the x-axis, so x2 is equal 0.5 length, y2. So the particle is placed on x-axis, y is 0. Okay, so that is 0.5 comma 0. That means the particle is lying on x-axis, y-axis 0. So the particle is 1, y x-axis 0. Okay, but here, so the particle on x-axis, y-axis is 0. Also, to find out the x3, y3. Okay, x3, y3. So x3, y3 here taken. So this is called as the distance between. This one is equal, here also like. So that means here totally 0.5. 0.5 is taken half of cut. That is called as 0.25. 0.25 comma. So to find out the y, okay, so on the y-axis, so taken, this is called as a length is taken y-axis. So to find out the this is called as the equivalent triangle OBA or OAB. OAB is taken. OAB triangle. So OAB triangle, so that is called as a sin 60 or cos 60. So sin 60 degrees, sin 60 is equal, or sin theta is equal, opposite side by AB by OB is taken. So sine, that is the equivalent triangle, each one 60 degrees. So 60 by AB. Okay, AB, so AB by OB. OB is equal, length is taken 0.5. Sin 60 is equal root 3 by 2. Root 3 by 2 is equal AB by 0.5. Okay, so AB is equal to, so 0.5 into root 3 by 2 to 0.25. So that is equal to 0.25 root 3. Now substituting here 0.25 root 3. Okay, got it. So now to find out the center of the mass of the three particles. Center of the mass of the three particles. So that is called as a m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3 xcm is equal. Okay, got it. So that is equal m1 is equal 100 grams, 100 x1 is equal 0 plus m2 150 grams, x2 is equal 0.5 plus m3 200. So x3 is equal 0.25 by 100 150 plus 200. Okay, 100 to 0 so 150. 15 5 is 75 plus 25 to the 50 by 200 300 450. So 450 we can write. So 125 by 450. So 5 2 so 10 5. 5 2 10. So 5 5 25. 5 9 45 0. So 5 5 25. 5 1 5 8. So 5 by 18. Okay, got it. So remaining YCM. So YCM is equal M1 Y1 plus M2 Y2 plus M3 Y3 by M1 plus M2 plus M3. M1 is equal 100, Y1 is equal 0 plus M2 is equal 150. Okay, so Y2 is equal 0 and M3 is equal 200. So here taken Y3 is equal 0.25 root 3. Okay, so by 100, 150, 200, 100, 150 plus 200. Okay, 100, 0, 0, 150, 0, 0, 200, 25, 25 2 is 50. So 50 into root 3 by 450. So 0, 0 cancel. So 5 on the 5 9. Okay, so root 3 by 9. Okay, root 3 by 9. So root 3 multiplication and divided with respect to. So root 3, 3 by root 3 into 9. 3 1 ja, 3 3 ja. Okay, got it. So that is called as a XCM comma YCM is equal to 5 by 18, 1 by 3 root 3. Okay. So this is called as a center of mass of the 3 particles. So center of the mass of the 3 particles XCM, YCM is equal to 5 by 18, comma 1 by 3 root 3. Got it. So today class is over and so we discuss the another topic next class. Okay, thank you students.